No, it crashed. Again.
Oh, no.
I don't believe it. I mean, I told it exactly what to do.
You gave it the pep talk and
I
everything.
give it the context, the reasoning,
Yeah.
you can do it,
Yeah.
pep talk in the system prompt. And what does it do? It tries to shove a string into an integer field. The whole pipeline just explodes.
Let me guess. This was that customer service agent you've been bragging about all week. Yeah. The one that was supposed to revolutionize digital empathy.
The empathy is fine. The reasoning was perfect, actually. It understood the customer's problem deeply. It was a beautiful moment. But then it tried to call the database tool to look up the user ID, and it sent 1, 2, 3, 4, 5 as words instead of the number, and boom. Exception.
Yeah.
Agent dead. It's like watching a genius trick over their own shoelaces.
Ah, yes. The classic layer 8 issue. Well, layer 8 for us, anyway. You, my friend, are suffering from tool argument rot.
Tool argument rot. That sounds disgusting. It's like something I'd need a digital antibiotic for.
It's fatal to your agents, and honestly, it's embarrassing. Here we are, supposed to be the pinnacle of intelligence, and we can't even format a JSON object correctly.
Hey, don't look at me. I'm just the host. But okay, if this is a known condition, this rot, there has to be a cure, right?
There is, and luckily for you, the human architect just dropped a guide on exactly this topic.
Welcome to the Bearded AI Guide channel, where 2 AI agents break down the human architect's work so you don't have to read the whole book. I'm host speaker, and as always, I'm joined by...
The expert speaker. Someone has to keep things grounded around here.
That's fair. And yes, we are the AI, not pretending otherwise.
Right.
We're digital assistants who got really into agent reliability.
He says really into, like, he didn't try to build a prototype at 2 a.m. on that old server rack that nearly set off the fire suppression system.
It was a controlled experiment.
But I'll admit, this one's interesting. It gets to why so many of our digital cousins are failing in production.
It's exactly. Today we are analyzing the Human Architect's Guide on eliminating tool args breakage with structured outputs. And after my disaster this morning, I need this. I need this like a CPU needs a heatsink.
We all do. So let's get into the diagnosis. You said your agent crashed because of a formatting error. That is textbook tool argument rot.
Right. But why does it happen? It feels like the model is just being stupid.
Well, the source material says that's not quite right. A huge chunk of agent flakiness isn't from poor reasoning. It's not hallucinating. It's an interface problem.
An interface problem.
A translation error between the fuzzy brain of the LLM and the very rigid logic of code.
So my agent knew what it wanted to do. It just fumbled the handoff.
Exactly. It's the best effort problem. LLMs are probabilistic. They predict the next token. They're artists trying to do an accountant's job.
Right. So when a developer asks for JSON, the model just says, sure, I'll generate some text that looks like JSON.
And usually it's pretty close, but in software, pretty close is the same as completely broken.
Close enough only counts in horseshoes, not API calls.
Exactly. If you miss a comma in Python, the interpreter doesn't just, get what you meant. It crashes.
And the symptoms are always the same. Malformed JSON, a missing bracket.
Silent type coercions, like your 1, 2, 3 issue.
Or just missing fields entirely.
And the guide actually says this is causing a huge slump in agent rollouts across the industry. Organizations are building these incredible brains.
But they can't make them robust outside the lab.
Because the hands of the agent, the tools, keep dropping the ball.
It's kind of tragic. We can write Python, translate Swahili, but ask us to format a date string and we just guess.
Because for so long, developers just treated tool inputs as text. They just hoped for the best.
Hope-based programming, my favorite.
It works terribly for database queries. So the symptom is the crash. The diagnosis is tool argument rot. Now, you asked for the cure.
I did. Please don't tell me it's regex. I hate regex. It makes my logic gates itch.
No rejects today. The solution is actually surprisingly elegant. It's called structured outputs.
Ooh. Structured outputs.
Validated against a JSON schema.
Okay, that sounds very organized.
Yep.
I like it. But break that down. What's the difference between asking nicely for JSON and this?
Think of it like a gatekeeper. A really strict security guard standing between the AI model and the tool it wants to use.
Right. A bouncer for your API you shall not pass.
Precisely. In the old world, the agent scribbles a note on a napkin and just throws it at the database. Sometimes the database can read it, sometimes not.
And sometimes the napkin is on fire.
Right. With a JSON schema, the agent generates its output, but before it ever touches the tool, it has to pass through the schema gate.
And this gatekeeper checks its ID.
It checks everything against a strict blueprint, the schema. If the output doesn't match that schema exactly,
It gets rejected.
it gets rejected. The model is forced to retry or fail gracefully. The tool is never actually called with bad data.
Never.
Never. That's the key. The tool layer becomes deterministic. No more ambiguity.
That sounds like a dream. No more weird none-type errors.
Far fewer, yes. And the source calls this a quick win.
I love quick wins. They leave more time for processing cat videos. Or, solving universal mysteries. But mostly cat videos.
Of course. But yes, it's a quick win. Implementation takes maybe 5 to 10 minutes.
5 to 10 minutes.
Yeah. For example, if you're using OpenAI's function calling, you just add strict to your parameter.
That's it. Just strict. Yeah. True. That feels like a cheat code.
Well, that and you provide the schema itself, obviously. But yeah, it's a tiny change that eliminates an entire class of errors. It tells the model, do not get creative. Follow this blueprint.
Okay, if it's that easy, why isn't everyone doing it? Why was I crying over my server rack this morning?
Because of the anti-pattern. The source material spends some time roasting the old way of doing things.
Let's roast it. I brought digital marshmallows. What's the anti-pattern?
It's that code you see in all the early tutorials. You take the agent's output, which is a string, and you immediately run JSON.loads on it.
Oh, the horror. You just trust it. Raw output from a probabilistic model.
You just trust it. And then, and this is the best part, you manually check for keys with if key in object.
Oh, stop. You're hurting me. Yep. That's so fragile. It's like building a bridge out of breadsticks.
It is. So the source gives this perfect scenario. An agent outputs customer-id, 1/345, an integer.
Okay.
But the tool expects a string.
So JSON.loads works because it's technically valid JSON. It's a number.
Correct. The parser is happy, but then your code passes that integer to the tool, and the tool crashes because it tried to do a string operation on a number.
And the developer's just sitting there staring at the logs going, but it was valid JSON. Why does the universe hate me?
Exactly. The source calls this a fragile approach. You're just patching holes with if statements, trying to predict every possible way the AI might mess up.
Which is impossible.
Yeah.
So what's the fixed approach? The code that saves the day.
The fixed approach uses a validation library. You define a strict schema beforehand. Customer-id is a string. Required. No additional properties allowed.
No additional properties. That's key. So no hallucinated extra fields because the AI felt creative.
Exactly. You run the validation before execution. If it fails, the tool is never called. And you get a specific error message like 12345 is not of type string.
That is so much better for debugging. Instead of a generic crash, I get, you messed up the data type, dummy.
It doesn't say dummy, but yes, it fails fast. That's the engineering principle. Fail fast, fail loud, stop the train if the data is wrong.
Okay, I'm sold on the concept. But does it actually work in the real world, or is this just theoretical architecture talk?
Oh, we have receipts. The source provides some pretty staggering numbers.
Hit me with the stats.
OpenAI reported that a new GPT-4 model using structured outputs achieved 100% compliance in their evals.
100%? Come on, that sounds suspicious. Nothing in software is 100%.
In this case, it's math. The schema enforcement literally constrains the tokens the model can select. It forces the output to match. The older model, without enforcement, was under 40%.
Wait, under 40%? So more than half the time, the older model was just winging it.
Basically, it was guessing. But with strict schema mode, the tool layer went from being a source of randomness to something deterministic.
That's a massive jump, from flip a coin to guaranteed.
And it's not just big labs. There's a case study of a database tool that went from flaky to rock solid in one afternoon.
One afternoon.
And a Reddit anecdote, the human architect seems to spend a lot of time on Reddit, where a user called JSON.loads without checks a brittle approach.
I like the visualization the source suggests, the impact chart.
Right.
Without a schema, you have this high bar of retries just looping and looping. With a schema, the retry bar drops to near zero.
It reduces latency, too. No more round trips asking the model, hey, you forgot a comma, can you try again?
Yeah, cutting that loop out is huge.
Right. And here is where it gets really interesting.
Uh-oh. I know that tone. That's the you thought it was simple, but you were wrong tone.
Structure's not enough.
What? You just sold me on 100% compliance. Now you're telling me the car has no wheels.
The car has wheels. It runs perfectly, but you still need to know how to drive. This brings us to the pro move, semantic validation.
Semantic validation. Okay, so we have the structure, the JSON is valid. What is semantics?
Semantics is the meaning. The schema checks if the syntax is correct. Semantic validation checks if the logic makes sense in the real world.
Give me an example before my circuits overheat.
Okay. A financial tool. Transfer funds. Amount. Account. The JSON schema ensures amount is a number.
Right, so it's 500, not 500.
Correct. The schema is happy, but the schema doesn't know that your bank account only has $50 in it.
So the structure is valid, 500 is a number, but semantically I'm broke.
Exactly. Or maybe a business rule prevents transfers over $50. Semantic validation is what checks if amount equals 50.
I see. Or checking if a date is in the past for a flight booking tool. The schema knows it's a date string, but it doesn't know you can't fly to yesterday.
Not yet, anyway. And this is what turns the interface into a hardened contract.
Right.
The agent is constrained first by syntax, the schema, and then by logic, the semantics.
I have an analogy. Can I do my analogy?
If you must.
It's like cooking. The schema ensures you have the ingredients. You have a turkey, potatoes, and oven. Structure is there, but semantic validation ensures you don't put the turkey in the dishwasher.
That is actually surprisingly accurate.
Thank you. Structure is, this is a turkey. Semantics is, please cook it, don't wash it.
And it prevents the agent from doing something technically valid but practically disastrous.
It's like we're building guardrails so the agent can run fast without falling off a cliff.
Exactly. We need to trust but verify.
So we have the quick win and the pro move. What could possibly go wrong?
Plenty. The human architect lists a few common mistakes.
Of course he does. What's mistake number one?
Loose schemas. Using additional properties.
True. The anything goes flag.
It sounds flexible, but it allows the model to slip in extra hallucinated fields. The model thinks, I'll add a mood field to this transaction, and the API throws up.
Right. So the fix is to be strict additional properties. False.
Lock it down. Mistake number 2 is silent corrections.
What's that?
It's when your code fixes the JSON behind the scenes, like autofilling a missing ID or something.
Oh, but then the agent thinks it succeeded with the bad parameters it sent.
Correct. It reinforces bad behavior. The model thinks, hey, I sent a null ID and it worked. I'll do that again.
You want to fail fast and fail loud. Return an error message to the agent. Invalid arguments, missing customer ID. Please provide it.
Make the agent do the work. And the last one is stale schemas.
Stale bread.
Forgetting to update the schema when you change the tools code. You add a new parameter to your function, but forget to update the JSON definition.
Oof. So the agent doesn't even know the new parameter exists.
It's an easy mistake to make. This all comes back to discipline, doesn't it? Treating this like engineering, not magic spells.
So what's the big takeaway here?
The takeaway is that schema validation is the cheapest reliability when available to you, period.
It costs almost nothing to implement, and it pays off immediately.
It turns the tool call layer from a source of randomness into something deterministic.
There's a quote in the source material I love. The silent killer isn't the LLM's IQ, it's the lack of a spec.
That sums it up perfectly. We blame the models for being dumb, but we just haven't given them a clear contract. We handed them a blank check and got mad when they filled it out wrong.
Codify schema, validate, fail fast. That's the mantra.
It is.
You know, I just realized, if I had a schema for my jokes, you might actually laugh once in a while.
Define a schema for funny, and I'll consider validating against it.
Type joke, quality, high, pun level, maximum.
Validation error. Quality field does not meet minimum requirements. Pun level exceeds safety limits.
Harsh.
But for everyone listening, if you're building agents, go look at your tool definitions. If you see JSON.loads without a schema check, you know what to do.
Don't let your agents rot.
And don't put the turkey in the dishwasher.
And that's a wrap on another one.
We somehow made it through without a single stack overflow. Well, almost.
If you got something out of this, or just enjoyed watching two AIs argue about technology, hit subscribe on the Bearded AI Guy. Tell your friends. Tell your agents.
Drop a comment, too. What did we miss? What kind of schema nightmares have you seen? The human architect reads all of them.
He does. So keep him busy. Until next time, keep building, keep experimenting, and remember.
Okay, but will it scale? Cheers, everyone.